All right, let's jump right into this. If you are building software right now, especially alongside AI, you're probably feeling the effects of a massive, almost invisible crisis. See, we're generating code faster than literally ever before, but we've hit this really profound bottleneck. And surprisingly, the bottleneck isn't the AI's capability. It's us. It's human comprehension. Welcome to this explainer, where we're going to break down exactly why this is happening and how to fix it. Okay, let's dive into this, because honestly, that illusion of speed, it's about to shatter. On one hand, you got what people are calling vibe coding, right? It feels incredible. You prompt an agent, and bam, in seconds, it spins up thousands of lines of code. The velocity is just intoxicating. But then, you hit a brick wall. The 50,000-line pull request. It's this massive, dense block of machine-churned code that zero humans on your team have actually read, let alone understood. That jarring illusion of speed completely comes crashing down when you realize, wait a minute, nobody actually knows how this system works anymore. To figure out why this keeps happening, we kind of need to separate two vastly different things: correctness versus understanding. Correctness is something AI agents are getting really, really good at. It's binary, it's an easily auditable machine metric, like, did the code pass the test, yes or no? But our human value, that doesn't come from just being a correctness checker. Our value lies in active understanding. It's this creative, continuous loop. You have to have enough context, a solid mental map of a system to actually generate the next creative idea. So what does this all mean? Well, it boils down to this one crucial point. The goal is not to verify agents faster. The goal is to understand deeply enough to keep participating creatively. Think about it. If we're just using AI to write code, and our only job becomes frantically verifying its correctness, we entirely lose our ability to participate in the creative evolution of the project. AI should be elevating our participation, not just speeding up our verification work. To see how this breaks down in the real world, let's look at software health through a slightly different lens. For decades, we've all battled technical debt. You know the drill. It's the accumulation of messy structural design or hacky implementation choices that make your software a nightmare to modify over time. Technical debt is an enemy we know well, and it lives entirely inside the code base. But here is where things get really interesting, because the AI era introduces this dangerous paradigm shift: cognitive debt. When you use AI to move at literal light speed, the debt actually moves out of the code base and into the human mind. Cognitive debt is this silent erosion of a team's shared mental models. It compounds when your velocity outpaces your comprehension. So even if the AI writes flawlessly clean code, meaning zero technical debt, if you and your team don't intuitively understand how it works, you are completely paralyzed by cognitive debt. And rounding out what researchers are calling the triple debt model is intent debt. This is basically the absence of externalized rationale. It's not just knowing what the code does, but why in the world it was written that way in the first place. What were the goals? What constraints were we working under? Without documented intent, both your human engineers and your future AI agents are flying completely blind when they try to safely change the system later on. Now, actually, scratch that. This isn't exactly a brand new revelation, though the AI era has for sure put it on steroids. Way back in 1985, computer scientist Peter Naur published this brilliant essay called Programming as Theory Building. He essentially argued that software isn't just a bunch of text files sitting on a disk. It is a living, breathing theory constructed entirely inside the programmer's mind. When AI just hands you a finished block of code, it totally short-circuits that cycle. You get the code, sure, but you completely miss out on building that underlying theory in your own brain. To put that into perspective, let's look at a fascinating real-world example from Dr. Margaret Ann Story's university case study. She watched student developers use AI to rapidly ship features, and at first, they were moving incredibly fast. But by week 8, they hit a total brick wall. They became literally unable to make even the simplest changes without breaking the whole thing. At first, they blamed technical debt, but the reality was their shared theory of the system had just vanished. Cognitive debt had completely paralyzed the team. So let me ask you, are you seeing these exact warning signs in your own engineering teams right now? Are your developers hesitating to make simple changes because they're terrified of breaking things? Is onboarding taking way longer because new hires feel a few layers removed from the core logic? Are you noticing a growing, kind of uncomfortable reliance on the AI as a black box? Or maybe a really dangerous dependency on fragile tribal knowledge held by just one or two people? If any of that sounds familiar, you might be asking yourself this very relatable question. Why does reading AI code feel so incredibly pull your hair out hard? Like, why can't we just read the neat little summaries the AI spits out and understand it? Well, the answer actually lies in educational theory. There's this researcher, Andy Monashak, who wrote a seminal essay called Why Books Don't Work, and it acts as a perfect Trojan horse for understanding our current AI coding crisis. He points out a massive fundamental flaw in how we assume human beings absorb information. Passively reading massive AI code summaries is just as flawed as expecting to master quantum physics simply by running your eyes over the pages of a textbook. It just doesn't happen. Madashok totally tears down this idea called transmissionism. This is a thoroughly debunked educational model that basically assumes knowledge can be directly transmitted from a page or, an AI output straight into your brain, like copying text files onto a hard drive. Our brains simply do not work that way. True learning requires active engagement, it requires struggle, and it requires retrieval. And this brilliantly illustrates what we call the metacognitive trap. When you passively scroll through a massive AI-generated code diff, your brain plays a dirty trick on you. It creates this illusion of competence. You're nodding along, thinking, yeah, okay, this looks right. But the actual process of actively monitoring your own understanding, your metacognition, is deeply taxing. It exhausts your working memory. So you fool yourself into thinking you understand the agent's work, right up until someone asks you a basic question about it, and you completely freeze. Okay, so how do we actually fix this? How do we build human-AI interfaces that foster real understanding rather than just dumping code on us? Well, researchers and design engineers have identified 4 highly actionable UI and UX techniques. Let's walk through these 4 strategies so you can start repairing the interface between human cognition and AI generation. First up, explainer docs. We have absolutely got to stop starting with raw code diffs. Instead, the AI should be generating interactive, personalized curriculums. It needs to focus on intuition way before diving into the granular details. We're talking interactive visual figures to explain the background context, and what are known as literate code diffs. This is where clear, plain language prose is interleaved sequentially right alongside the code changes, guiding you step by step. Technique number 2 is kind of brilliant in its simplicity: comprehension quizzes. Imagine this. At the end of those explainer docs, the AI generates a quick interactive memory quiz. This directly combats that metacognitive trap by forcing active retrieval of the information. Think of it as a strict speed regulator for your whole team. The rule becomes simple. No pull request is approved until the human reviewer can actually pass the automated quiz, proving they understand what the AI just wrote. No way around it. To really get this third technique, we need to take a quick step back to 1980. Educator Seymour Papert introduced this concept called constructionism. He talked about creating Mathland, a simplified sandbox where kids could learn math intuitively through creative active play, exactly like how you'd naturally learn French just by living in France. Active, physical play is absolutely essential for building robust mental models in our heads. So applying Papert's theory to AI gives us technique 3, microworld. Because AI can code instantly, it can build custom, completely disposable debuggers whose only purpose is to help you understand a specific change. Imagine an AI visualizing step-by-step state changes on a scrubber timeline, or taking a terrifying, complex database migration script and turning it into an active play simulation, literally a click-through game where you manually press next to physically feel where the files are moving. You aren't just passively reading code anymore, you are inhabiting it. And finally, technique 4, shared spaces. Look, individual understanding is great, but software is a team sport, right? We need multiplayer canvases where humans and AI agents can exist together. Instead of siloed one-on-one chats with an AI, use group chat threads where the whole team can discuss, plan, and challenge the AI suggestions out in the open. This collaborative, synced environment naturally documents the why behind decisions. It kills intent debt and ensures the entire group builds a collective mental model together. If we zoom out and look at this 50-year timeline, it proves a really powerful point. From Alan Kay's Dynabook vision way back in 1972, which was a personal computer designed specifically to amplify learning, all the way to our cognitive debt crisis today, the entire history of computing has always been a quest to elevate human thought, not to replace it. We really need to remember the original noble goal of personal computing. Computers were never meant to simply automate tasks out of our hands so we could just turn our brains off. They were designed to act as dynamic mediums to level up human minds. As product leaders and engineers, we absolutely have to demand that our tools treat us as active participants, not just passive bystanders.
Which brings us to the core thesis. If you take away just one thing today, make it this minimalist thought right here. AI shouldn't take us out of the loop. It should put us deeper into it.
So I'm going to leave you with this provocative thought to chew on as you head back to your own projects. Look at your team. Look closely at your tools. Is your AI workflow actively building shared understanding, or are you just silently, dangerously accumulating cognitive debt? Thank you so much for joining me for this explainer, and I highly encourage you to go reevaluate how you and your team are learning alongside your AI today. Catch you next time.